Hello, and welcome back to the Ninox Learning Channel. My name is Andy. I'm a Ninox programmer and trainer, and in this class, we're going to explore a topic that's always popular, and that is data visualization, charting, and graphing. Drawing pictures or creating a visual aspect for the data, the information, and the business intelligence that we capture, enhance, and store in our Ninox solutions. Now, this is always a popular topic because this is where the information and the intelligence come to life. This is where they take on a graphic and visual component that numbers in a column or records in a row simply cannot present. But we want to be careful. There's lots of visual options and capabilities in the Ninox visualization engine. We want to make sure that we use them correctly and sparingly, because when you're talking about charting and graphing, yes, a picture is indeed worth 1,000 words, but there's another saying that's also appropriate, and that is less is more. Simple, basic charts and visuals that let the information tell the story, that let the business intelligence shine through, are far more powerful and far more persuasive than lots of bright colors and all sorts of pictures that at some point become hard to understand because you're not quite sure what you're looking at, and pretty soon it kind of becomes visual noise. A simple, well-conceived, well-drawn chart or graph or visualization is one of the most powerful ways to use the information and the business intelligence in your Ninox solutions to educate people, to entertain people, to motivate people, and to persuade people. There's a right way and a wrong way to do it, and we're going to look at the right ways to do it here in this class. So let's go ahead and begin. Now, for this particular training session, we're going to use a database of customer invoices. And we have a table here, table number 1, that consists of just a little short of 400, exactly 390 invoices. And in fact, if you've been with us for some of our other training videos, you've seen this database many times before. Now, the first thing that we want to talk about is where we do our data visualization. And before we talk about that, we want to talk about how Ninox draws its pictures. You've heard me many times use the words data, information, and business intelligence. And many people make the mistake of thinking that these are synonyms or that these words are interchangeable, and they most certainly are not. They are three very, very different things. Data, or what you've heard me refer to in previous classes as characteristics or discrete pieces of information, tell us something about the object of a record. For example, here is an invoice number 70,000, that was for a transaction for a customer named Prime Intelligence. There are individual pieces of data like the date, the salesperson, the dollar value of product, service, and warranty sales, the type of customer. These are pieces of data. These are pieces of data that tell us something about the object of this record. And the object is this invoice. In this case, invoice 70,000. Data, when compiled and summarized, becomes information. For example, we may ask, what is the dollar value of invoice 70,000? And very clearly it is $1,733 US. That is data. That is a characteristic or something that describes a quality, in this case the dollar value, of this one particular invoice. If we were to go back and say, what is the total dollar value of all invoices? Well, we can see right here by clicking on the sum button and looking at the bottom of our page, it's $758,957. That is information. The amount of one invoice is a piece of data. The amounts of all of the invoices summarized or averaged or in some way mathematically or statistically manipulated or some calculated value is what we call information. Data is transformed to become information. Information, when compared to a baseline, delivers intelligence. For example, we know that we can look at one invoice, see how much that invoice is worth at the bottom line, and we are looking at data. If we take all the invoices and add all of the bottom lines together, we have information. How much did we sell to all of our customers via all of our transactions last year? Now, if we take the total sales, that piece of information, and we compare it to the total sales from the year before, and we then look at the change, we now have intelligence. Did our total sales go up or down? And if it went up or down, by how much? And is there a reason? Can we understand why sales increased or decreased? And intelligence is not necessarily related just to dollar and arm's length transactions or commerce records. You're probably at this point asking yourself, why does any of this matter? Because when we talk about data visualization, when we talk about drawing pictures, we are talking about information and intelligence. We very rarely, almost never, would draw a picture of a piece of data. The important thing to understand, and this is the second topic that I said we were going to talk about here at the beginning, is to understand how Ninox draws its pictures. How does it visualize or chart or graph our data, which has been turned into information, which can deliver intelligence? First, it takes the raw data and it mathematically compiles it. So if we had 100,000 invoices from the last year, and we wanted to summarize those invoices into 12 monthly buckets, and then have the sum total of sales for each of those 12 months, and then present that information in a bar chart where the more sales we had, the higher, the taller the bar is. If we wanted to do all that, two things have to happen. First, those hundreds of thousands of invoices need to be mathematically and statistically manipulated to turn the data into the information. Then, and only then, can the information that is now numeric be turned into a graphic or visual presentation or data visualization. Two very important things have to happen. Now, ask yourself this. If you had to do two very important things, would you want to do them both at the same time? Or would you want to do one and then do the other? Ninox is the same way. When given the option of doing two very complicated things at once, or doing one thing, doing it right, and then moving on to the next, Ninox is just like us. It would rather do one thing at a time than multiple things at a time. So that leads us to the first step in data visualization. And this is something that you have heard me talk about in past classes here on the Ninox Learning Channel. And that is that when we are analyzing data, whether it's statistical or mathematic, whether we are visualizing or graphing or charting it, when we are looking at our data, the first thing we want to do is get out of the table or tables that we're looking at. Think of it as a tree. If you're cutting down a tree, you don't want to be in the tree when you're doing it. If you're analyzing the invoices table, you don't want to be in that table while you're trying to analyze that table. So the first thing we're going to do is step out of the table that contains the data that we are going to analyze and eventually draw pictures of. So you'll see that we have table 1, which is this table right here. And these are all of the individual invoices that we have in this database. We're going to step out of that table and move over to table number 2. Table number 2 is a table that we have set up whose sole purpose is to take the raw data in table number 1 and summarize it and analyze it and mathematically and statistically manipulate it so that we have the information that we need to then draw the picture. Let me show you what I mean. In the invoices table, and I'll just pull up one invoice at random, we have a field here called year sort. You will also note when I go into edit my fields that we have fields for month sort, which looks like this, and numeric month. And I'll take the null out of there so we can see these fields. We have these little fields that were hidden from view, which tell us things like the number of the month of this invoice, or the year of the date of this invoice, or when sorting by month, the numeric value of the month and then the name of the month. Because if we showed months alphabetically, we would get April and August before we got January and February, and that's not correct. So here we have a field that gives us the number of the month followed by the name of the month. We hide these fields because they're not necessary during the process of entering and analyzing and manipulating customer invoices. But having a single field, which gives us the numeric value of the month in which the invoice was cut, makes it very easy for us to summarize all invoices by month. If I want to summarize all of July's invoices separately from all the invoices from the other 11 months of the year, I only have to find invoices where the numeric month field equals 7. I just draw a very simple formula here in the invoice summary table for July, and the formula is this. Invoice total for July is equal to a selection of invoices where the month equals whatever value M is, and we are summing up the total value of the total invoice field. Now, in this case, it happens that the value for M is 7. The period code for July is the 7th month based on a calendar year, so July is 7. So, select all invoices where the month of the invoice date equals 7, take the total invoice field from all of those invoice records, and sum it up. And with 2 very simple lines of code, we now have tens of thousands, or in some cases, hundreds of thousands of invoices summarized, totaled by month. We did the first thing, and we did only the first thing. We summarized all of the invoices for the month, in this case, period 7, the month of July. We also looked at the first quarter, the second quarter. We totaled up total product sales for that month of July, separately from total service sales, separately from total warranty sales. So the first thing we did was we took all of the raw data from table number 1 and we mathematically and statistically manipulated it and analyzed it and turned that data into information that answers the question, how much did we sell in each month of the year? And I want that answer broken down by month. We did that first by stepping out of the invoices table where the data was and creating a second table, which is where the information now exists. Now that we have all of this information, now we will ask Ninox to do the second thing, draw a picture of it. So here we have the 12 months of the year, January through December, and the 4 quarters of the year, first, second, third, and fourth, all nicely summarized and packaged into a simple table, which is my table number 2, the invoice summary. Now I simply draw a picture, in this case a stacked bar chart, and I'm going to click on Edit Columns to see what I'm charting. I'm charting the month code, and the month code are these values down here across the horizontal or the X axis. O1 is January, O2 is February, O3 is March, all the way through 11, 12, and December. Okay? So we have our x-axis labels, which is the month, and the next field is the invoice total. This establishes the value for the y, or the vertical axis. This is the axis right here. The x-axis, which runs left to right, is the labels of what we're seeing, and the y-axis, which runs bottom to top, is the value of what we are seeing. And specifically what we want to see is the total product, total service, and total other or warranty sales. And then there's a fourth field here to give us the sum total of those three other fields. So we stepped out of invoices where the data was, created a second table, and used very simple formulas to analyze that data and turn it into information. For example, our total product is, for each month, the invoices table, all the invoices for a particular month, the sum of the product sales for all of that month's invoices. Very simple, very basic, and as you can see, short code blocks, which give us now a very powerful asset. All of our invoices turned into information. Now we simply go in and we say we want to draw, in this case, a bar chart, and we indicate what we want. This is where things get a little bit interesting. When we talk about what we want, there are three components to our chart. This is a bar chart, or we will generically call it a visualization. The first field, the first text field that Ninox encounters of all of the visible columns in the chart, that is going to be your x-axis. That's going to be the label of the x-axis. The first text field here is the month code. The month code is a concatenated field, which consists of the number of the month enclosed in parentheses, followed by a space and the name of the month. It is the first text field that Ninox encounters, therefore it will be our x-axis. The next numeric field that Ninox encounters, this is the second field, but it's the first numeric field, that is going to be the scale, the numeric reference point of the y-axis, the axis that starts at 0 at the very bottom and runs all the way up to 160,000 at the very top. Ninox will calculate the scale appropriately, which is to say, if you have invoices that range from 1 penny to $1 million, Ninox will start with 0 at the point of intersection where the X and Y, where the horizontal and vertical axis meet. That will always be the point of 0. And at the very top, at the highest point of the y-axis, Ninox will say 1 million. And then it will calculate the appropriate number of tick marks and the dollar spread between tick marks to give us this scale. Here we see a scale that ranges from 0 to $160,000, and it is drawn in $20,000 increments, or $20,000 ticks. So let's go back to the edit columns. The first text field will be your x-axis, your horizontal axis. The first numeric field will be the y-axis, your tick marks, or the range or scale. The remaining numeric values, that's right, we can't draw pictures of alphabetic text or text fields in general. Pictures or data visualizations are graphic representations of numeric data. The remaining numeric fields in the visible columns area of this visualization define what is plotted or placed inside the XY grid that was created by virtue of the horizontal X and vertical Y axis. In this case, four values: invoice total, and the components of that total: product, service, and warranty sales. Let's look at it in its visual form. The purple component, that is total other or warranty sales. The turquoise blue, total service sales. The green, total product sales. And the red, total sales. Now, we have a redundancy here that is making this a rather misleading visual presentation. The invoice total is the sum of product, service, and warranty sales. So we don't need to have the components and the sum of the components on the same chart at the same time, because we've doubled everything up, which now enables me to show you a really cool feature, and that is you can turn the elements or the components in a chart on and off. In this particular chart, I don't want to see the total invoice. I want to see it broken down by component. I click on invoice total and it goes away. The chart redraws itself and we now see our sales by month by component. This is what we call a stacked bar chart. So we can see trends, we can determine intelligence and understanding of how our business performed, at least from an accounts receivable and billing financial perspective, over the 12 periods of the year. Now let's say we want to break this down even further. I want to see only product sales for each month. We turn off service, we turn off other, and there we go. Total product sales. Now, here we see a much different picture. If we look at total sales for the year, it's really pretty even. The highest month and the lowest month, well, there's not that big a delta between them. However, if we look only at product sales, we see a very different picture. There was a significant decrease in June and a significant and very material increase in November. This intelligence will enable us to start asking questions. Good intelligence is the result of asking good questions. And knowing which questions to ask is the result of analyzing our information. If I simply looked at this, I'm going to turn off the components and turn on the total. Now I'm seeing total sales per month without the breakdown of product, service, and warranty. And I would look at this and say we had a pretty stable year. And I might erroneously conclude that things are very smooth, things are very balanced and even. But if I analyze product sales only, it's not quite as smooth. We saw a significant progression over the first 4 months of the year, then a precipitous decline from April down to June. It was not nearly as smooth a year as we thought it was if we're looking at product sales. Service sales tell us a very different story. Now, in fact, November was not even our best month. If I look at total product, June was the worst month of the year. But if I look at total service sales, June was the best month of the year. And if I analyze warranty sales, May is off the charts and June is back to being the worst month of the year. There's very valuable intelligence being presented here in this simple stacked bar chart. Now, when we talk about data visualization, we're not just going to talk about how to create the picture. I want you to understand how to read and analyze and use the picture to get the intelligence that Ninox is presenting, because it is this intelligence, this highest level in the data maturity life cycle, that is the real value, the real power, the story that Ninox can help us tell. And the first thing that we've learned is here in the key or the index, and this is the index up here at the top, we can turn different elements of our chart on and off to learn different things. The next thing I want to do, staying with this bar chart, and again, we're going to look at the three elements on a monthly basis. Products in green, service in turquoise, purple is our other or warranty sales. But now we're going to unstack these individual elements and look at them as components of each individual month. Again, we don't need to look at total invoice and the three components that make up the total. I'll turn total invoice off. Now we're starting to see lots of stories being told at the same time. So we use the bar chart, whether stacked or unstacked, to visually annualize on a comparative basis how much of something we had compared to how much of that same thing we had in a different period and how much of other things we have in the same period. Compare that to a line chart, which would look like that. The line chart is the same thing. It's still the same amount of money. We're still charting the same invoices, but now we are doing it in a very different fashion. Instead of having 12 points of reference, which in this case were the 12 months of the year, we are now seeing 4 points of reference, the 4 quarters of the year. You cannot differentiate what amount of area at each point. And here are the 4 points. First quarter, I'm now hovering over under second quarter, third quarter, fourth quarter. These 4 points, or plotted points on the grid, represent the first, second, third, and fourth quarter of sales. The lines connecting those 4 points represent the trend, and that is the difference between our bar chart and our line chart. Bar charts show us a comparison between categories or elements, where line charts show us trends over time. How did we draw the line chart? Let's go to Edit Columns and find out. Very simple. The first numeric values, are, again, the first one, which is numeric, sets the scale on the y-axis. The first text field, which happens to be this month field, sets the key or the scale for the x-axis. But I've stipulated something here. Of record types, I only want quarterly records. Remember, my summary table has 16 records in it. 1 record for each of the 12 months of the year, and 4 records for each of the 4 quarters of the year. Different pieces of information, which is simply different ways to analyze and assess the exact same data library. All of my data is in table number 1 invoices. All of the summarized information of that data is in the number 2 or invoice summary table. I stepped out of my data table so I could then analyze that table. The analysis was done across 2 different time periods. Monthly periods, and there are 12 in a year, and quarterly periods, and there are 4 in a year. I analyzed on my bar chart only monthly periods. Here where it says record type, I specified only records that are monthly records. There were only 12 of them in the table. So only these 12 records are visible. For the line chart by quarterly, or my quarterly sales trend, I specified only records that are quarterly records. There are only 4 of them. This is a very pointed chart. There's this little switch over here, this yes/no fields that's asking, do we want to smooth out the lines? It's a personal preference, but if you click it, you'll get a little bit less of the mountain peak and a little bit more of a roller coaster. Same data, same information, same visualization, just different styles depending on how you want to present your picture. The other thing is some of the options that make sense for one chart, for example, stacking or unstacking the elements in our bar chart, they don't necessarily make sense across all charts. Now let's move on to another kind of chart, another kind of visualization. Again, we're going to be analyzing the same data using the same computed, calculated, or compiled information, but we're going to use a different picture to tell us a somewhat different story or provide us with a different kind of intelligence. And this is the pie chart. Now the bar chart, the line chart, and the pie chart, these are the three most common charts that we see being used across businesses, across schools, nonprofits, families, governments, manufacturers, real estate. Doesn't matter what kind of business you're running or if you're running a business at all, but when you're visualizing or charting or graphing your data, I think you'll find the bar chart, the line chart, and the pie chart to be the most common and in many cases the most simple or intuitive, easy to understand. Let's take the same four pieces of information, total sales by quarter, and look at it not as a trend, but as what we call a pie chart. And a pie chart is very, very different from the charts that we've seen so far. The biggest difference being there is no axis. There is no XY vertical, horizontal definition of a grid. Now, there is an axis here, but it looks very, very different than it did on this very square YX or XY graph or chart or grid. Obviously, not much of a grid here, a very different shape, telling us a very different story. Now, we see four elements corresponding to the four components. First quarter in red, second in green, third quarter in turquoise, fourth quarter in purple. And each of those elements each of those quarters consists of four elements: total sales and product, service, and warranty sales. Let's look at edit columns. We have all of our sales by quarter, but four sets of numbers went into each of these quarters. So we have the four quarters represented by the colors, and then we have the four lanes which represent the elements within each quarter. Now, what does the bar chart tell us? It again shows us, and the intelligence that it delivers is comparative. How does one quarter compare to another? And here, again, we see what appears to be a very stable year where it's almost exactly 25% of our sales were achieved in each of the four quarters. And we see them compared by quarter and within each quarter by element. How does the chart get drawn? Again, we use the Edit Columns button to indicate which fields we want to have included. I'm using the record type field only to specify I want my quarterly records, my four quarterly records. I then want those numbers, first, second, third, fourth quarter, consisting of October, November, December, different than first quarter, which is on a calendar year, January, February, March. The way we draw the charts is the same no matter what kind of chart it is. With the click of a button, my pie chart could become the line chart, or for that matter, a bar chart. And if I stacked the bars and did not show the totals, this would be my quarterly sales by quarter shown in a bar fashion versus the pie chart. And again, you can turn elements on and off. If I want to look at the first half of the year, I would be looking at the first and second quarter. I'd turn the third and fourth quarter off. This ability to turn elements or components on or off is an extremely powerful piece of the Ninox puzzle, the Ninox picture engine or visualization engine. Now, we've looked at 3 different charts and spent a considerable amount of time looking at how we read those charts. Let's take a few moments to understand how we draw the charts. We start the same way that we would do any view. Charts, all of these different kind of charts, are merely a different type of view. We click the plus sign to create a new chart, and we select Chart. In this case, let's say I want to again draw a bar chart of product sales by month. I know we already have one, but let's draw another one. So this will be product sales by month. And it's going to be a chart view. Now, I'm going to click on the title of this newly created visualization or view and select Edit Columns. I could have just as easily done it by clicking the Edit Columns button here. None of this is what I want. I don't want quarterly numbers, so I'm going to hide all of these quarterly numbers. I want this by month, so I'm going to make the first field the text field, and the text field is going to be the month field. This will give me my key across the x-axis. I want 12 of the 16 records in my summary table, notably the 12 monthly records. Don't want the 4 quarterly records. And what do I want? I want total product sales for each of those months. Click OK. And, well, that looks a little bit strange. It's my total product sales, but I'm seeing all the months stacked on top of each other, so all I know is that I had almost 300,000 for the year. If I unstack the chart, that looks a little bit better. I have January here at the beginning in red, and my product sales in January were $18,165. My product sales in November, a high for the year of $37,013. And no, you cannot specify the colors. Ninox does select the colors for you. I can turn months off. For example, maybe I want to look at the first month of each quarter of the year, which is January, April, July, and October. And there we go. There's the first months of each of the 4 quarters of the year. So while the numbers don't lie, they sometimes tell irrelevant truths. So make sure when you use the Edit Columns function to draw that graphic data visualization, make sure you are getting the right components to tell the right story the right way. Quarterly stories don't give us monthly detail. And monthly detail can mislead us into conclusions or intelligence that is not accurate. But all charts are drawn exactly the same way. By clicking the plus button, naming the view, I'll just call this name of view, selecting chart, and we've already looked at the table, the form, card, Kanban, and Gantt, so we have chart, and then within the chart, picking the specific type of chart you want to see. The bar, and you can stack or unstack the bar. The line, and the lines can be stacked or unstacked. They can be smoothed or sharpened. And the pie chart. And for those of you that don't like pie, you can have a donut. Same data, same 4 elements, across the same 12 months of the year, just a different visualization of that information. We can see charts drawn on XY grids. We can see charts drawn with no grid or axis at all. And this leads us to the final 3 charts that we're going to talk about in this class, and that is the polar, the radar, and the bubble. The polar and the radar chart are area representations. They show us the value of data based on the amount of space that that data consumes. Let's go in and look again at this bar chart. And let's turn this bar chart into an area representation. We draw it the exact same way. Now, when we are looking at area charts, detail matters. An area chart where there's only, and we'll look at the polar area chart first, where there's only 4 components, doesn't really tell us a whole lot. When you're using area charts, and these are sometimes called heat maps, we draw them the same way. Click the plus sign, name the new view, define it as a chart view, and when it comes up, select the polar area or the radar chart as your area presentation or visualization. Now, where bar charts represented big numbers with tall bars and small numbers with low bars, where pie charts represent big numbers with bigger slices of the pie or bigger elements, and small numbers with smaller pieces of the pie and smaller elements, the polar area and the radar chart represent big numbers by taking up lots of space and small numbers by taking up less space. Now, in this case, the total space taken up by this radar chart is the interior of the 4 points being plotted. First quarter, second quarter, third quarter, and fourth quarter. And we can see that from third quarter to fourth quarter, there was a big uptick. From the first quarter to the second quarter, there was a slight downturn. From second quarter to third quarter, there was a significant downturn. Now, unlike the pie chart or the donut chart, which are themselves area charts, where they do show us the values by virtue of space. Big values taking up lots of space, small values taking up less space. These space visualizations, notably the polar area and radar, have a grid. They have an axis. It is a grid where 0 is in the middle, and as you go further and further from the middle, the numbers get bigger and bigger. Here we see that the first quarter was the worst quarter of the year because it's closest to the center, and the center point is the 0 point. We see that second quarter and fourth quarter were the best months of the year, with fourth quarter being the very best month because it's the furthest away from the 0 point or the middle. Now, there are 2 aspects to drawing the chart. The first one is using the edit columns function to tell Ninox what you want to see. The first text field will be the x-axis. And if there is only one axis, and in this case, in this chart, there's one axis. The area chart, or in this case, the radar chart, the 0 point is in the middle, and all space that emanates out from the middle, the further we go out, the bigger the numbers they are. In all cases, the first text field will be either the x-axis, or in the case of a pie chart, donut chart, polar area, or radar chart, the only axis. Where there are 2 axes, an x and a y, and this is notably in our bar charts and in our line charts. Let me see if I can even find a line chart. Where there are 2 axes, the first text field will be the x, or horizontal axis at the bottom. The first numeric field will set the key for the y-axis, the up, down, or vertical axis, in this case on the left. All other numeric fields will serve as the points that are plotted in that XY grid or that XY area. Some charts have no grid, notably the pie and the donut. And other charts have a grid consisting of one element, notably the radar chart, the heat map, or the area chart. But remember, when drawing the area charts, you will get far more intelligence out of the area chart if you have more points of data. Here on this radar chart, we are plotting three elements, the same three elements we have seen all along. The green element is product sales, the turquoise element, service sales, and the warranty or other element, the purple sales. The more space each color takes up, the more dollars were earned for that category of sale. And for each point, here is the January service point, the February service point. Note my axis runs the perimeter of the area, with the 0 point being at the center. Each point that makes up the area is a different month. The further away that a point is from center, the bigger the number. The larger the area that is within all of the points when you connect them with a line, the bigger the amount of that particular element. And what do we see of the extremes? Which are the 3 months that are furthest away from the center 0 point? For product sales, that's clearly November. That was my best month for product. And it's no surprise that this point, the November point in green, is furthest away from the center. My best month for service sales, well, that was June, because it is this point that is furthest away from the 0 center point in blue. And blue or turquoise is our service sales. And our best month for warranty sales, it is May. May is the furthest away. Which was the worst month? Well, it's a toss-up between June and February. Those are the 2 points that are closest to the center 0 point. It's all the same data being summarized or transformed into the same information, monthly and quarterly information based on individual invoice data. We are simply selecting different pictures to give us different information and different intelligence that is used to drive different decisions. But the way we draw all charts, all data visualizations, is the same. We click the plus sign, we name the view, we select chart, and then we pick what kind of chart we want to see. And within each chart, there are different options. For instance, we can look at our bar chart where we have the data is in the columns. This column represents the values or numbers, or we can flip it where the data is in the row, and now we have all of this by month and for all 4. And this, let's turn off the we would turn off the total. So here we have for each type of sale: warranty sale, service sale, product sale, total sales, broken down by month. There are 12 elements for each of those 4 categories that are being drawn. This exact same chart will tell a very different story and look very different when we make it a radar chart or a heat map and we flip it to column versus row. I am not changing the underlying data. I am not changing the underlying information. I am merely changing how that data or compiled, computed information is being presented. To draw the chart, select a new view, select the text fields that will make up the x-axis, the numeric field that will make up the scale when there is a y or a second axis, and the numeric fields that will be the information, the content plotted in the charting area. This is the charting area. And whether your chart looks like this, or this, or this, the charting area is where the picture is drawn. But don't forget where we started. To get these charts and to make it so easy to draw the chart, simply going in and having my 12 months, my 4 quarters broken down by product, service, and other, and all of that broken down by month, there's some pretty complex computations here? I don't think so. These are very simple computations. In this case, 1 month or 1 line of code. In this case, total product sales by month, 2 lines of code. And one of those lines is just setting a variable. Simple, easy, basic, small code blocks. But if we use a summary table to summarize the numeric data, and we first create that summarized information, and then we draw our pictures in the summary table, you'll find it far easier to get the visualization you are looking for. I want to conclude by reminding you there's no reason you can't draw pictures of the raw data itself. Here we see total sales by month in a bar chart form, broken down by sales component, product, service, and warranty, and we stack it so we can see our trends over time. The exact same picture using the exact same data will look this way if we draw a picture of the data versus the picture of the information. This is a picture, a bar chart, stacked bar chart of the summary, the information. What would this look like if I went in and summarized the raw data? Here's my 390 invoices. I'm going to click the plus sign. I'm going to do an invoice bar chart. So I'm going to name it, select chart, and click OK. The columns that I'm showing, the customer name is the first text field that Ninox selected. All the customers listed at the bottom, and every one of these bars is actually an individual invoice. Remember, I told you, charting data is often less valuable than charting compiled information, where information is computed out of the data. There are some ways to analyze our data, and those are the Kanbans and the cards broken down by month or broken down by year. You can draw visualizations or pictures, but they're not quite as useful depending on how you draw them. A pie chart of 400 invoices, as you can see, summarized by customer, not going to be real valuable. So, we analyze data, we turn it into information, we draw pictures of the information, and by comparing the graphic representation of the information, we derive intelligence. Sounds like a lot, but it's very simple. Create a table to summarize your data. Within that table, click the plus sign to create a new view, select chart, and then select edit columns to indicate which pieces of data or summarized information you want to see. Don't want the invoice total in there? Fine. Hide that column and the chart will redraw itself. Don't want the green section? You only want to see product and warranty sales? No problem. Turn them off temporarily by clicking on service and toggling it in the key or the index, or go into edit columns and remove it or hide it entirely, and the chart redraws itself. And that is data visualization in Ninox. Click the plus sign, create a new view, name the view, select chart. And then you've got all your different chart types. The bar chart, stacked or unstacked. The line chart, which shows us trends, and it can be pointed or smoothed. The pie chart, which shows us comparative values where big values take up lots of space or big pieces of the pie or donut, and small values take up smaller values. The polar area or the radar chart, which are area charts where bigger areas represent bigger numbers and where distance from the center 0 point, the further the distance, the bigger the number. And the final chart, and quite honestly the least used, is the bubble chart. The bubble chart is the one chart out of all the Ninox charts that can be used to draw across three axes: the X, the Y, and the Z or the Z axis. Bubble charts allow us to analyze data in 3 dimensions. I want to be clear, it does not draw 3-dimensional visualizations. It allows us to analyze data or computed information on 3 different axes. And for more information on the 3D bubble chart, we're going to have that covered in one of our next videos coming up, and that is our advanced data visualization. That's the 600 level series, which will be starting in a couple of weeks, where we get into some of the most advanced topics in Ninox. And one of those in advanced data visualization will be the 3-dimension bubble chart. I hope you've enjoyed drawing pictures with me in this class. Pictures aren't worth 1,000 words. Data words, probably better off with Kanbans and Gantt charts, cards and table views. Computed information, step out of your table, compute the information, and then draw pictures of the information. The information contains the data, and I think you will find that pictures of information are far more valuable than pictures like this, which are pictures of the raw data itself. Thank you so much for joining me, and thank you for being part of the Ninox and the Ninox Learning Channel community. I hope you learned something, I hope you had fun, and I hope I get to see you in our next class. Thanks for joining me. Thanks very much. Bye-bye, everybody.